Ever wondered how your brain processes information? Now, imagine a machine doing the same. It's not just a figment of science fiction, but a reality in the form of artificial neural networks, or ANNs for short. These are computing systems inspired by the human brain's biological neural networks. Just as our brains use neurons and synapses to process and transmit information, ANNs use artificial neurons or nodes. Think of these nodes as tiny information processing units, receiving, interpreting, and passing on data, much like the neurons in your brain. This network of artificial neurons works together in a similar way to our brain's network of biological neurons. The beauty of ANNs is that they can learn and evolve. They adapt based on the information they process, fine-tuning their responses over time. So, in essence, an ANN is a computing system that learns and evolves, much like our own brains. Think of an ANN as a multi-layered cake. Each layer has a specific role to play. The bottom layer of our cake, the input layer, is where we feed in our data. This could be anything from images, audio, or text. It's like our raw ingredients, ready to be transformed. Then we move on to the hidden layers, the middle part of our cake. These are where the magic happens. Just like how the raw ingredients are baked into a delicious cake, the hidden layers process the input data. They find patterns, make calculations, and pass the results onto the next layer. Finally, we reach the top layer of our cake, the output layer. This is where we get our final result, the prediction or classification. It's like the icing on the cake, the part we've been waiting for. Just as each layer of a cake contributes to the overall taste, each layer of an ANN contributes to the final output. Scene script. How does an ANN learn? It's like fine-tuning a recipe to get the perfect dish. You see, the learning process of an artificial neural network, or ANN, is driven by training data. This data is akin to a chef's cookbook filled with recipes. Each recipe represents a data point that the ANN uses to learn. Now, the ANN doesn't just blindly follow the recipes, it tweaks them, adjusting the ingredients to make the dish even better. These adjustments in our ANN are called weights and biases, and just like a chef, the ANN uses a special process to make these adjustments. This process is known as backpropagation. Backpropagation is the ANN's taste test. It's how the ANN checks if the tweaked recipe is better or worse than the original. If the dish tastes better, the ANN keeps the changes. If not, it tries different adjustments. So learning in an ANN is all about adjusting these weights and biases, just like tweaking ingredients in a recipe. From recognizing your face to suggesting the next movie to watch, ANNs are everywhere. We may not realize it, but we interact with these amazing technologies every day. Ever wondered how your smartphone knows it's you every time you look at it? That's image recognition, one of the many real-world applications of ANNs. In fact, ANNs power the facial recognition systems that keep your personal information secure. Let's consider another familiar scenario. You're browsing through a streaming platform and suddenly a movie recommendation pops up, perfectly aligned with your taste. That's the work of ANNs, powering recommendation systems. They analyze your viewing history and suggest content you might enjoy. And it doesn't stop there. Ever heard of autonomous vehicles, cars that drive themselves? Yes, ANNs play a significant role there too, helping vehicles understand and navigate the world around them. So the next time your phone recognizes your face or you get a movie recommendation, remember it's all thanks to ANNs. Like all technologies, ANNs have their limitations but also hold great promise for the future. Just as too much of a good thing can lead to overfitting, ANNs also require massive datasets to function effectively. However, don't let these hurdles dampen your spirits. Picture a future where advancements in deep learning take ANNs to new heights. Imagine the evolution of neural network architectures, making them more efficient and versatile. Despite these challenges, the future of ANNs is exciting and holds endless possibilities. So, what have we learned today? We've unraveled the mystery of artificial neural networks, likening them to our own brain's network of neurons. We've dissected their structure into simple layers, akin to levels in a game. We've understood how they learn, much like perfecting a recipe. We've seen their practical applications impacting our everyday life. Yet we've also acknowledged their limitations while looking forward to future advancements. As we continue to explore and innovate, the world of artificial neural networks will only become more fascinating. Stay curious.